So today we are starting our Unit 3, Radiation Basics. Before we get started, let's look at the digital notebook. Make sure you put your name and your class block in there. The table of contents, you can see the days we are doing different subjects, and the test and notebook for this will be Thursday the 17th. So basically a week from today. This is a shorter unit. So the first one is fission and fusion, and that's what we're going to go over. So first, let's start by talking about different radiation basics. In 1895, German physicist Wilhelm Röntgen accidentally discovered a new form of energy, which he called the X-ray. Since his first X-ray was actually of his own hand, and this work sparked feverish research, especially in Germany, about what caused this, and they come to find out it is a form of radiation. In World War II, the physicists understood that splitting the atom would release a lot of energy, so they used that to help make the bombs. The Manhattan Project, which actually happened in Oak Ridge, was a secret project to create the atomic weapon. There was a site in Hanford, Washington, where they made the plutonium fuel, Oak Ridge, where they make the uranium fuel, and then Los Alamos is actually where they put the two together and made the bomb. So in July 1945, this happened, and it was a lot of radiation that we're going to kind of cover throughout this entire unit. What happened, what causes it, all that good stuff. So the reason why the atom used or put off all that energy is it wants to be stable. So an atom is stable based on its proton to neutron ratio. If there are too many or too few neutrons or protons, it'll give off that excess energy until it is stable, which that's also known as radioactive decay. Of course, the faster it gives off the energy, the more powerful it is. So what is radioactivity? You do need to know and underline that word, and the definition for that is unstable atoms that emit radiation to gain stability. Radioactivity is when substances spontaneously emit radiation. The particles that are emitted is called radiation. A reaction that involves a change in the atom's nucleus is called nuclear radiation. And when these changes occur, it'll form new atoms. This proves that every atom does have its own unchangeable properties, because radioactive substances do change their own properties. So unstable elements, like we've already talked about, that's where there's too many neutrons, so it's going to give off that energy to get rid of those neutrons to make it stable. There are two types of radiation. The first type we're going to talk about is ionizing radiation. That is where the energy is given off by the nucleus. It is strong enough to detach an electron from the atom. So this type of radiation is so strong, it basically splits the atom. So when the atom loses an electron, it has a positive charge, and it's called an ion. And the ion and its lost pair are called the ion pair, which we'll talk a lot about ions in the bonding unit. And then the other type of radiation is non-ionizing radiation, which energy in transit that's too weak to detach an electron from another atom. Example of that is like your light, your radio and television waves, your microwaves, things we'll talk about in depth at the end of this unit. Radioactive decay, you'll need to know the definition for this. That is when an atom's nucleus gives off excess energy. The process is called the radioactive decay. And you also need to know what a half-life is. That is the time it takes half the radioactive atoms to present to decay. And that brings us to fusion versus fission. Nuclear fusion is the process by which multiple nuclei join together to form a heavier nucleus. This is accompanied by release or an absorption of energy depending on the masses of the nucleuses or nuclei involved. Energy needed for fusion. So you need a lot of energy in order for this to happen. If you've ever taken like physical science or physics, you may have heard of kinetic energy or potential energy. And that's basically, it's having to overcome that energy in order for this to happen. And then that brings us to nuclear fission, which an atomic nucleus of radioactive elements splits by the bombardment from the external source, which simultaneously releases a lot of energy. This is used for electrical power generation. So fission is exothermic, which means it releases a lot of heat. Which that's going to bring us to the second video that you see on this slide, which I do want you to watch as well. And it's basically talking about what nuclear power is and how radiation can be a good thing. All right, so in your digital notebook, you will need to answer these two questions. You can use what you know already, or you can use the internet if you need help answering these questions.